have a look at calculating UTC and DR position of civil twilight on the morning of 28th of June, and we're going to do the double approximation method. So we're given our time on the ship as 14:30 UTC, we're given our course and speed and our current latitude and longitude. So let's apply the longitude to our present time on the vessel and get our local time on the vessel, and we find it's 20:31 on the 27th, so naturally sunrise will be next available for us will be the 28th. So we'll go into the tables 28th, using 28 degrees 06, and we interpolate using 8 degrees and 6 because we're going from 20 to 30. Remember, we always go from lower to higher, and the difference between the two is 19 minutes. So you use the 10 degree column, go down to 8 degrees, read along the top the difference, come down, and we find that the difference is 12. So we apply that the difference was 16. So we come down, yes, 8 across to 16 there. So that would be the interpolation that we would use. So that means 611 plus the 16 is 627. So June the 28th, local time is 627. Let's apply our longitude in time, and that gives us 0006 hours on the 28th of June. Now we've got the universal time, we can compare that with the current universal time on the ship, and the difference between the two will be our steaming time for the first approximate position. So get the local time of twilight, civil twilight, convert it with your longitude to universal time, compare that with the time on the ship, and that gives you the steaming time. Plain sailing or Mercator will give you your first approximate position. Now we carry that forward to use in the almanac by interpolation to get the actual universal time of civil twilight that we require. So again, 20 degrees and 30 degrees, now using 27 degrees 27.5. By interpolation now we get 14 minutes, so that gives us 0625. So our universal time now is 0015 hours, and in the first instance of course we got 0006 hours, but now we're going to, which is written here, 0006. After applying that to our first approximate position, we get 0015 hours. Now we can work out our second approximate position because we've now can work out the actual steaming time to use. So the steaming time for the second approximation will be this difference here and the time on the ship. So now we're going to be steaming for 9 hours 45 minutes as opposed to the 9 hours 36 minutes for the first approximation. Get our distance run, course and distance, Mercator or plain sailing, apply to our position on the ship, and that will give us the approximate DR for civil twilight using double approximation method. So first approximation, then get that position, carry that forward to get the second time, which is the time you want for civil twilight, then use that steaming time to get your actual position or approximate DR for civil twilight.